and wish you all a happy learning. This is Yam Nirmala working as Assistant Professor in the Department of Computer Applications, Hindustan College of Engineering and Technology. And I'm here to give you a small short lecture on logistic regression along with an implementation problem. Logistic regression is basically a classification algorithm. Supervised learning is being categorized into classification problem and regression problem. Classification problem is the one which deals with target variable to be in a categorical representation, and regression algorithms are the one where the target variables will be in the form of continuous numerical data. And to go on with, in general, logistic regression is a classification problem, or we can call it as a predictive algorithm. And here the target variable will be categorical. In general, by looking into the data set, it has been categorized into input features and output features or target variables. So the independent variables can be either numerical or categorical, but the dependent variables or the output variables or the target variables should be in the form of a categorical representation with respect to logistic regression algorithm. And here logistic regression is a statistical model which uses logistic function to model the conditional probability. And this algorithm can be used for binary class classification or multi-class classification. And the function which is getting operated here are called as sigmoid function to represent the logistic regression hypothesis. To give you a small differences between linear regression and logistic regression are, linear regression is a regression algorithm model and logistic regression is a classification algorithm model. And the basic differences between regression and classification algorithms are the target variable separation. In case of linear regression, the target variable will be in the form of continuous numerical data. And in case of logistic regression, the target variable will be in the form of categorical data. And the linear regressor values ranges between minus infinity to plus infinity, which means, as we said, that the target variable are in the form of numerical quantity, which may range between minus infinity to plus infinity is the concept given as linear regressor values. In case of logistic regressor, it lies between 0 and 1, which means either you may have a S or no representation. So here it comprises of only categorical representation. And linear regression function is in the form of equation of a straight line y is equal to mx plus c, and logistic regression is applied with sigmoid function, and the formula is 1 by 1 plus e to the power minus beta naught plus beta 1 x. So if you are able to apply a log transformation or logistic representation to a linear regression algorithm, it will become an sigmoid function or logistic regression problem. And what are the basic assumptions for logistic regression? The logistic regression algorithms to get applied with the data should never contain an outlier. What does mean by an outlier? Let me give you a simple example. Let's take that a student can get a maximum mark of 100 in a class. Suppose by mistake on a typographical representation, or I have given a typographical error, like a student has secured a mark of 1000, which means it is an outlier in the data, because on a maximum the student can fetch only 100 marks, but I have given a typographical representation of 1000 for a particular student, which cannot come into the range of a student marks, which we call it as an outlier. So we have to be with utmost care that the input variables should never contain any outliers. And the second important assumption are there should never be any correlation among the input variables. So in general, the data set is getting categorized into two representations. One you call it as an input data and other one is your target variable or output data. So an input data can be a single parameter or it can be multiple parameters put together in a given data set. We have to ensure that the input data, if it is of multiple representations or multiple features representations, then there should never exist any collinearity between the multiple input features. So all the input features can be dependent on the target variable, but they should never be dependent among themselves. So these are all the two assumptions which needs to be ensured before going to the logistic regression algorithm. And to go on with a simple diagrammatical representation, linear regression goes with the equation of a straight line as y is equal to mx plus c. And if your straight line is squeezed into an S curve representation, then obviously it becomes the diagrammatical representation of a logistic regression. And here we are going to show you a simple implementation of logistic regression for a problem. Thank you. Thanks for watching.
Herewith we are going to show you the logistic regression algorithm implementation. The problem which has been taken into consideration here is the classification of a gender case study. This particular data set comprises of 10,000 rows which has height, weight and gender of a person. We have to build and train a model on this data set so that it can predict the gender of a person given their height and weight. The basic process which needs to be done for every machine learning algorithm are we have to import the necessary pandas packages, numpy packages. All the necessary library files needs to be imported here. So the packages which has been imported here are pandas and numerical python, and import OS is the operating system package. The purpose of the operating system package are we have to identify where our exact data file is located. What is the present working directory? Where our particular data files are available. All these informations can be performed using the operating system packages. In this particular implementation example, I have taken my data set weight height.csv file and it is being stored in the location /machine learning /ml 2023 ml /lab. So I'm going to change my current working directory to this new directory. So let me run this particular code. Now I have to check whether the current working directory has been changed. So my current working directory is now /machine learning /ml 2023 ml /lab. Now the next process is to load the CSV file. So we are going to load the weight height.csv file which is available in this particular location, and it will be converted to a pandas data frame. The name of my pandas data frame is df. The choice of keeping the name of the pandas data frame is up to the user, and in my case I've kept my pandas data frame name as df, which is data frame representation. And now let me run this particular code. Now after running the pd.read_csv file, let me run it, and my data file is now displayed on the pandas data frame. I have my gender, weight, height columns displayed on the screen. It contains 10,000 rows and 3 columns. Now we will go for analyzing the data set. This data set contains 3 columns: gender, height and weight. Height is given in inches and weight is given in pounds. And after running df.shape, it gives me an output as 10,000,3, which means totally you have 10,000 rows and 3 columns. And what is the purpose of df.dtypes? Df.dtypes is data types. So what does the particular columns data type refers to? So let me run this particular code. It shows that gender is an categorical variable which is represented as object. Weight and height are numerical quantity represented as float 64. If you want to know the statistical informations of the numerical quantity. In this particular example, the statistical quantities are weight and height. If you want to know the numerical statistical informations on the numerical data set, then we can give describe command. On executing the describe command, it gives me the information as what is the count, what is mean, what is standard deviation, what is the minimal value, what is the 25% value, what is the maximum value, and so on. Next is df.info. The purpose of df.info is to identify the data type of the variable. So here it contains gender with 10,000 non-null values which is of object data type, weight 10,000 non-null values with float 64 data type, and height 10,000 non-null values with float 64 data type. Now to check for empty values. In order to check for empty values in the data set, we use the function called as isNull.sum. Now on executing this particular command, my output shows that the data columns with null values is 0. For gender also you have no null values. For weight also you have no null values. For height also you have no null values. On the whole, this is a clean data set which does not contain any pre-processing operation. Now these statements like selecting only the numerical columns and selecting the categorical columns are applied only when you have more input features, which means the size of the column variables are high. But in our case, we have only 3 column values, which means these particular statements can be skipped. Next is df.dtypes gives you the information of the gender as object, weight and height as float 64. There is one mandatory principle when you are going for a model building operation. All the input feature variables should be converted to numerical quantity. In this example, we have the gender categorical variable. So now this gender, which is a target variable, has to be converted to a numerical quantity. So for that we are going to use the label encoder. So the label encoder is a conversion process, encoder process, which can directly replace male as 0 and female as 1. So now these particular cell helps to convert the male values. All the male will be replaced by 0 and all the female value will be replaced by 1. On executing, this is my output, right? So now let me show you the tail representation. The tail command will help you to display the last 5 rows of the given data set. Now all your gender values is been converted into one representation, right? Now let me give you one more representations of head. So let me run the command by df dot head, and on executing it shows me the first 5 rows of the data set. So now all my male and female are been appropriately converted into zeros and ones representation. But still, when you execute this d-type representations, it shows that gender, even though on conversion to 0 and 1 format, its data type is not been converted. Still it is a categorical representation. So now we have to go for the next representation of converting the gender categorical variable to an integer representation. As the gender object is categorical, we have to convert that into a numerical quantity. So df of gender is equal to df of gender dot as type of int. So this command will help you to convert the categorical gender variable to a numerical gender variable. Now let me prove it by running this df.dtypes. Now the gender is converted into int 32. So now your data set is ready for the model building operation. All the values in the data set are converted into numerical representation. Now I'm going to import my sklearn.model underscore selection, which is a package for performing my model building operation. And every data set will contain both input and output variables, and it is our mandatory procedure to divide your data set into X and Y representation, where X refers to input features and Y refers to target variable. According to our example, input features are height and weight, and target variable is gender. So now X column is equal to df dot drop of gender. Leaving the gender column, all the remaining columns will be taken as your X variable, and Y is your gender column. So now on executing this particular statement, there will be an separation of X and Y values. Now on executing this command, X comprises of height and weight values, and Y comprises of gender values represented in the form of 0 and 1. Now we have to divide the given data set into training part and testing part. Training part will be used to train our model, and the testing part will be used to test our model and to get the correct predictions. So we are dividing the given data set into X-train, X-test, Y-train and Y-test representation. So this particular line helps you to divide your X and Y column into X-train, X-test, Y-train, Y-test. So for that we are going to use a command called as train underscore test underscore split, and X will be divided into X-train, X-test, and Y will be divided into Y-train, Y-test. And what is the test size? The test size is equal to 0.2, which shows that we are dividing the data set into 80% of training data and 20% of testing data. Suppose if my test size is equal to 0.3, then it shows that 70% of the training data and 30% of test data will be accompanied in this particular problem, and my random state is equal to 0, and the purpose of random state is equal to 0 will help you to select data rows randomly. If you does not want data rows to be selected randomly, then we are going to give the command as random state is equal to 0. Now on executing this particular command, my given data set is splitted into X-train, X-test, Y-train, Y-test on the ratio of 80%, 20%. Now in order to show, or in order to ensure that whether the values have been divided based upon 80-20 representation, let me run this X-train column. X-train column is divided as 80% of the data. The total number of rows are 10,000. So my X-train data comprises of 8,000 rows. 8,000 rows of height and weight. And my Y-train comprises of 8,000 rows of Y data. X-test, so 2,000. So here X-test is your testing data, which comprises of 2,000 rows, and Y-test is the 2,000 rows of Y value. Now we are going for the concept of model building. For more logistic regression algorithm, I am going to import the logistic regression package. So from sklearn.linear underscore model, import logistic regression. For that I am going to create an object called as logic model. Right, the name of this can be anything as per your own choice, and in my case my model name is logit model, and I'm going to create a object based on the logistic regression algorithm. And the next step is the fit command. Now the data has been divided into X training, X test, Y training and Y test. Now I have to go for the concept of training the data. Now only the split up has been carried out. The next representation is for training the data. For training the data, the command used is fit. So for fit command, always the training data will be provided. So the training data are X train, Y train. So here X train and Y train variables are passed as the input parameter for the fit command. And in order to know what is the training score, right, the training score is evaluated by means of a command called as score. And now after calculating the score of the training data, let me run this particular command. When executing it, the logistic regression training score is 91.8375, which is a very good score. Now we go for the evaluation metrics. This is my training score. The training score is evaluated based upon score command, and the testing score can be evaluated based upon accuracy underscore score. So now you are going to predict by using a command called as model name, that is log it underscore model dot predict of x test, and you're going to calculate the testing score by the command accuracy underscore score of what is the data you want to give for testing is your y test and the predicted score. And now on executing this particular command, my output is still more increased and the logistic regression testing score is 92.25. So in general, default the training score will be always high, but the testing score might little bit go down. But in this particular problem, the training score is 91.8 and the testing score is 92.2, which is both are almost similar in nature. Now I have to check my model whether it is able to give me the correct gender. So for that I am going to take up an test data. So I am going to take the test data from this particular location. So let me, okay, so here the name of my test data or the test data which I am about to give you is the weight value 66.172 and the height is 136.77, and I have to get an appropriate gender value of 1. Let me copy this command. Let me copy these values. And I'm going to fix it here. This is to get an output of 1. Let me take one more example to get an output of 0. And now let me take my height, weight, range test. Before doing it, let me show you the right. Now let me take this to get an output of 0. 73.84 and 241. Now let me run it. So on executing this particular cell, I'm getting a perfect output. For the first case, I expected an gender value to be 1, and for the second case, I expected an gender value to be 0, which has been appropriately displayed. So this shows that this model building has been successfully executed. Thank you for watching. Have a good day.